For example number 3, part A, we want to sketch a right triangle that corresponds to the trigonometric function of the acute angle, theta, and then we want to find the exact values of the other 5 trigonometric functions of theta. So the first thing I'm going to do here is I'm going to draw a right triangle, which is what we have. And now we're going to put theta in, and it is really entirely unimportant in which angle we put theta. As long as it's not the 90-degree angle, it doesn't matter if you put it up here, if you put it down here. It's entirely unimportant. The answers are going to be the same either way. So I'm just going to put it down here. And I'm going to start off and label the sides of the information that we know. So this tells us the secant of theta is 6 over 5. Now remember that secant is the reciprocal for cosine. And cosine is adjacent divided by hypotenuse. So this is telling us that secant is going to be hypotenuse divided by adjacent. Okay, I'm just going to write this up here. I was quickly going over this in my head. SOHCAHTOA. Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, so I know that secant is going to be hypotenuse over adjacent. So what this is telling us is the hypotenuse is going to be 6, so let's label this side 6. And the side adjacent to theta, and this is our side right here, that's adjacent to theta, that's going to be 5. The first thing when we're done sketching or putting these two sides, and the next thing you should notice is that we're missing this side over here. Let's call this side x. You can call it whatever you want. It's unimportant. So what we're going to do is we're going to use the Pythagorean theorem because we have a right triangle to help us find x. Now the Pythagorean theorem tells us that leg squared plus leg squared is equal to hypotenuse squared. So we're going to call it x squared plus 5 squared is equal to 6 squared. That's the same thing as saying x squared plus 25 is equal to 36. Subtract 25 from each side. That's the same thing as saying x squared is equal to 11. Take the square root. Don't forget your plus or minus. That's the same thing as saying x is equal to plus or minus the square root of 11. But with the understanding that we're dealing with the distance, it is a quadratic equation, but it's a quadratic equation that relates us to the distance, which is the side of a triangle. We're going to get rid of the negative. So what that's telling us is that this value x over here, or the side opposite of theta, is the same thing as saying positive the square root of 11. Once you have all 3 sides, then it's just a matter of banging out the trigonometric ratios and making sure that you have your ratios memorized or making sure that you write them down properly. So we know that the sine of any angle is equal to the side opposite divided by hypotenuse. So the side opposite of theta is the square root of 11. And the hypotenuse is 6, this side over here. We know the cosine of any angle is equal to the side adjacent, which is 5, divided by the hypotenuse, which is 6. And we know the tangent of any angle. Tangent is opposite over adjacent, so the side opposite is the square root of 11, and the side adjacent is 5. Once you have the first 3, the last 3 are just the reciprocals, so you can just flip them over. Let's see, so the cosecant of theta, if we flip sine, cosecant's going to be hypotenuse over opposite, or 6 over the square root of 11. Keep in mind here that this is not rationalized. So, sorry, let me just draw a little barrier here to give us some more space. So when we go to rationalize it, we're going to multiply the numerator and denominator by the square root of 11 over the square root of 11. And the cosecant of theta is 6 square root of 11 divided by 11. The secant of theta, well, we already know the secant of theta because that's the information we were given in the beginning, but notice it's also the reciprocal of sine. So if we flip 5 over 6, we're going to get 6 over 5. And then for the cotangent of theta, well, tangent's opposite adjacent, so cotangent's going to be adjacent over opposite. So 5, here's the side that's adjacent to theta divided by opposite, which is the square root of 11. And again, we have to rationalize it because we have a radical in the denominator. So this is the same thing as saying 5 square root of 11 divided by 11. And here are our 6 trigonometric ratios, 1, 2, 3, 4, 5, 6, based on these initial conditions.